Debugging. So debugging is part and parcel of a life of a web developer. From my past experience, I have noticed certain patterns, do's and don'ts, and I'm going to share it with you so that the next time you encounter a bug, it'll be a lot easier to fix them. So to make it easier for to remember, I'm going to take you through the lens of a detective. I am Mariam Reba Alexander, and I am a software engineer working at Bursk, and I had been doing front-end web development for the past 5 years. And these are the tech stack that I had been working with. On a day-to-day basis, I work with vuejs framework, Jest for unit testing, and Cypress for end-to-end testing. And I had been largely involved with developing the logistics hub dashboard for Merce.com. And it is powered by AI, and it has consolidated views of the shipments and the task and logistic updates for the Merce.com customers. So the picture that you see here is that of the map, one of the main features that I had been involved with, where customers can track their shipment. On a personal note, I'm originally from Kerala, south of India, and I moved to Copenhagen, Denmark for about 5 years ago. And in my free time, I like watching murder mysteries, especially Agatha Christie series. And these two are my favorite characters, Hercule Poirot and Miss Jane Marple. And I like how they solve every difficult mysteries with their clever brains. Now let's come into the topic of debugging. As I mentioned earlier, I'm going to take you through the same approach that a detective takes for solving a mystery. Let us go through them one by one. So the first stage of solving a mystery is to look for clues, just like going into a crime scene and gathering some evidences. So what kind of clue do you look for when you are trying to solve a bug? The first clue that a developer should look for are console errors. As soon as you notice something is not right, open the dev tools of your browser and check it whether there are any console errors. Most of the time, there lies the first clue to your problem. Now, these are some of the usual errors that you will see in the console. One is a type error or reference error. Now, type error occurs when a value is not of expected type. And second is the anonymous script errors. And the third is the syntax error caused by some invalid JSON. And fourth is the network errors. Now let's look at some of these examples and how you can fix them. So the first kind of error that you see here is uncaught type error, cannot read properties of undefined, and this happens in Chrome. Now let's see, I have defined a variable called let ice cream, and I'm trying to access a property flavor of this undefined object. So now it throws the error, cannot read properties of undefined. In a real world example, it may not be so evident as the example that I showed you before. Here is an example application where it shows some suggestions when you are bored. And what happens right now is it shows a blank page initially with just the image, and then it throws a console error. And you can see a similar error happening in this console as well. Type error, cannot read properties of undefined. And it's trying to access some property of an undefined object. Another example of type error, undefined null is not an object. And this happens in Safari. It's the same error, but with a different wording depending on what you're trying to access. So are you trying to access on an undefined object, or are you trying to access on a null object? So then the error depends on what you're trying to access on. So the first case is undefined is not an object. The second is null is not an object, because the second case you have defined it as null. And the usual fix is to define it. And second is to check with if conditions whether it's null or undefined. Third is using optional properties. Now, if your web application is monitored using monitoring tools, you may literally see a lot of errors described as script errors without much explanation about what the error is. Now, these errors are usually unhandled errors sent by the browser. And if you look at the web session, you may typically see a script error caused by CSP issue, as in the example that I've shown you here, due to serving a script from a non-listed origin. And if you look at the code here, you can see content security policy configured in a meta tag. Now, content security policy is an added layer of security that helps to detect and mitigate certain types of attacks like cross-site scripting and data injection attacks. So in this code, here you can see it's configured meta tag and also a script tag, which is loading a script from a different origin called cdn.jsdeliver.net. The way you can fix this is by adding the CDN URL that you're trying to fetch it into the cross origin, the content security policy meta tag. So here I can see that you have added the CDN into the content attribute, and in the script tag add a attribute called cross origin anonymous, and which means that you are not passing any potential user identifying information like cookies or HTTP credentials to the by the browser to the server that where you are requesting the file from. Another fix would be to set the header as access control allow origin on the server side. And this is how you could set in this is an example of Node.js server, how you could set this header. And you could also add multiple URLs where you want to allow the scripts to be loaded from. The next type of error that you normally would see is the JSON parsing errors caused due to some invalid JSON you're trying to parse. So this is an example where you're trying to parse a string, which is an invalid, and property names the property name should be double quoted, otherwise it will throw in the same unexpected token error message. The third is if you have any trailing commas, then you would see the similar JSON parse error. So far I talked about looking for clues in console errors and went through some examples of type error, script error, and syntax errors. Let's go into the next stage of investigation, that is collecting witness statements. So when a detective interviews a witness, he normally takes them into a private room in order to hear the different version of stories and determining who is speaking the truth and who falls into the suspect list. So likewise, when we find an issue or a bug in the app, let's test them in an isolation to find out the actual problem is. And how do we do that? It is by cross-checking in various environments. One, by comparing it in cross-browser. Second is by comparing with another system. And third is by comparing commits. Now, the usual suspects are, so if you find that it is a browser-specific issue, then the reason behind it is some missing fallbacks or polyfills or some workarounds that is required for the unsupported browser feature. Now, if you find as machine specific, then it may be that your branch is behind commits, do a git pull, or maybe that there are some missing packages, then do an npm install. And third, empty your cache and reload. Sometimes the browsers cache very heavily, especially during development. Then the next cause would be a network request failure, or even a token expiry, and your API may not give you will give you some authentication errors, and your UI will behave differently. So these are some usual checks that you can do before you jump into solving an issue. Now let's get into the interesting bit of the investigation, that is narrowing down suspect lists. Many of the times in the first two stages, you would have already found the culprit of the issue. In other times, you need some further investigation and further digging. Now, DevTools. Just like Detective's magnifying glass, DevTools is one of the most useful tools. I'm sure that every developer will agree that. And it makes the developer's life much, much easy. Now let's look at different ways of using DevTools to inspect the running application. When I don't see a DOM content loading, I would like to see the DOM structure in the Elements tab. And additionally, here is an example on how you can inspect DOM elements using Console Utilities API. So you can inspect a property of an latest element by typing $0 into the console, and then it will print out the particular DOM element. Alternatively, if I want to access any property of that element, I can simply write here in this example I've given $0.text content. It will give you the text content that's inside the div element, and I can manipulate the text content dynamically through this property. And the next time you inspect another element, that would become $0, and the previous inspected element, you can access it, still access it. It will remember you can access it by $1, and then you can do the same operations that you have done before. Breakpoints. Pausing the execution using breakpoints, I'm sure that it's the next popular way of debugging after console log, of course. So it's normal. You can see breakpoints. You can do it by opening the sources tab and clicking on the line of code that you want to pause. Conditional breakpoints, it will allow you to pause on a line of code only when a certain condition is met, and that you can do it by right-clicking on the line of code and clicking on edit breakpoint, and then a particular box will pop up where you can add the expression. And in this case, I'm trying to check if a certain response.entries is defined, only then pause. And after saving that, it would appear as orange. In the normal breakpoint is appearing as blue color, and here you can see it appears as orange and with a question mark, indicating that it's a conditional break. Watch. Instead of adding a console logs to certain values or expression at certain points of code, the watch pane can be used. And here the values get refreshed during when you refresh the sources tab and while stepping in through the code. So here you can see you can click the plus icon, add the expression there, and here I'm trying to access the response object, and you can add any condition. Say response.length is greater than 0, then it would give you the value true or false. So here I'm have in the example I have attached here, I have put response, and it would give you the populate the value of the response object when the breakpoint is paused. Alternatively, you can use live expression in the console pane by clicking on the eye icon. Here you can add an expression, and the interesting thing is that you could see it. You could see it in the value changing in real time. Now let's revisit the problem that we found in our demo app earlier. So looking at the code, you can see there is a response object, and this is coded in vuejs, and so that's the structure that you see now, and it has a function defined inside the mounted. So whenever the app loads, it calls this function, and it's called get suggestion. And inside the get suggestion method, I could see I'm using Axios to fetch from a public API for the data, and it's getting it gets used in the HTML using response.data.activity. And by using live expressions, I could see that when the page was blank, the response.data was undefined, thrown an error saying response is not undefined. And after the content got loaded, the response.data had value. So That means at some point of time, the response data is undefined. That means I have to add a weave condition in the template saying weave response.data because the HTML loads before the API gets called and there's no data at that point of time. So by adding weave condition, it fixed the problem. And now the app is working. Now, another feature of Console Utilities API is monitoring window events. So you could monitor window events using monitor events and passing the window object and the name of the event that you want to watch. So the next time, for example, I want to watch a certain event called resize, and whenever the window is resized, the event is triggered, and I can see all the events getting logged here. And you can also use along with the $0. So for if you not only window events, you can monitor events on a certain element by passing in the inspected element $0 inside the monitor events argument. And every time here I am in this example, I am monitoring the events that is being triggered on the certain button, and every time I hover over it or if I click on it, it logs it out in the console log so we could see whether the event is working or not. So next, how could you figure out how the UI behaves when a certain request fails? So the way you can simulate is by blocking the URL. You can do this by looking at the network panel and right-clicking on a certain network request and block request URL. So the next time you load the application, that particular request is blocked, and you can simulate how your UI behaves whenever a certain request fails. Next is saving request as HAR. Now, suppose your QA has found an exceptional error that is not handled for a particular data response happening in production, and the network request and the response data can then be stored in a HAR format, which stands for HTTP archive format, which can be uploaded later, and you can download them and upload in the browser to simulate the same request on a different system. So this is a very useful feature. Another useful feature in DevTools is copy as curl. I use this a lot of times. If you want to tweak certain post requests to see what kind of data you receive, you can copy the network request as curl, which then can be imported into a tool like Postman to simulate the request. So this way it is easier than inputting all the network headers and payloads manually into the Postman app. You could do this easily just by copying and importing. Now, there are many different DevTool extensions which are framework specific, which is really useful for debugging. And one for Angular, it's called the Angular DevTools, and React, it's React Developer Tools, and for Vue, it's vuejs DevTools. This can be imported, and these extensions can be downloaded from Chrome Web Store. So far, I talked about how you can leverage DevTools for debugging, and let's look into the different ways how you can leverage Git for debugging. So the one is the most common way of doing is git diff. So suppose you had a working version of the application and you introduce a bug in the next commit, you could take a git diff and compare where you have introduced a bug. Second is git blame. So git blame gives you the last author of that particular line of code, and you can also see the time in which that it was committed, so you could find out at when did you introduce that bug. Git bisect. Now suppose you had a working version of the code and after a lot of commits, you realize that you introduced a bug somewhere in between those commits. Now Git helps you by Git helps you to Git bisect will help you to do a binary search to traverse back into the commit that introduced the bug, and by allowing you to tag the commit as good or bad until you find the commit that introduced the bug. So it's not so easy to explain here in this short time, but there's a very good documentation available in Git. Please go through that if you're interested to know more. The fourth additional point that I want to mention was always remember to ask for help when you're stuck with an issue. And that's because a second pair of eyes will always help to spot the bug easier. So even here you can see the great Hercule Poirot require help from Captain Hastings from time to time. Now let's go into the last stage, is capturing the culprit. So this is where we want to go. So you can capture a bug by using error handling, using try-catch statements, and you can also do it by writing unit test cases. I've noticed that while writing unit test cases during development, it captures a lot of bugs beforehand before it gets into the production. And a lot of logical errors can be captured while doing end-to-end test cases. Now, after your app goes into production, it's always a good idea to monitor your application from the error logs, and where you can identify certain unreported bugs, and you can also watch for certain anomalies and make fixes for it beforehand before someone reports the bug. Now let's look at a summary. So we went through how we can detect a bug through the eyes of a detective by looking for clues in console errors, and by collecting witness statements, cross-checking in browser and systems, and by narrowing down the suspect list by using techniques with DevTools and Git, and finally by capturing with test, error handling, and monitoring. So with that, if you have any questions, please put it in the chat. And I'm also available in Twitter at Mariam Reba, and I also have a blog post where you can visit and read my posts. Thank you for listening to my talk, and I thank JSWORLD Conference team for giving me this opportunity to speak in this platform. And I hope you will remember all these techniques that I have taken you through the next time you will do debugging. Thank you so much.